So in today's session, we are going to look at 10 numbers on numeration, the topic. Now, numeration involves, things like factors, multiples, prime numbers, sequences, and number bases. What you're going to be doing are simply past paper questions on this topic, and definitely they are adopted from UNEB. So let's get started. So just like the way it is when you want to gain muscle in a gym, you do not gain muscle by just looking at people lifting weights. It is one thing to look at them on a video lifting weights, but that's all you will do. You'll just look at them and nothing will happen to you. If you also want to gain muscle, you will have to physically participate and start lifting the weights. So it's the same thing here. I'll be doing these numbers. If you just sit back there and just watch me do them, that's all you will be. It will just be like you're just watching some movie. Nothing will happen to you. You won't be able to learn anything. If you want to learn, you need to actively participate. So I would recommend that you grab a paper or you grab a book and a pen and your calculator. And before I do the number, if you feel you have an idea on the number, first pause the video. Then first try out the number, see which answer you get. Then afterwards, play the video to see if my calculation arrives at that answer. In so doing, it would mean that you are actively participating and not just watching, and you'll be able to learn a thing or two. So with that preamble, let's get started. So this is a number adopted from an examination past paper question. To be precise, this is UNEB, this is number 1 to UNEB 2010, paper 1. So they are saying that if 125 base n is equal to 82 base 10, find the value of n. So let me rewrite this thing here. 125 base n is going to be equal to 82 base 10. So for us to be able to find the value of n, this side here, as you can see, is this thing here is base. This is base 10. So it means that we are supposed to convert this to base 10 as well. In the process of converting that side to base 10, we will be able to find n. Now, if you've been told that 2, 1 base 3, let me just do this as side work. Converting 2, 1 base 3 to base 10 would mean that converting that to base 10, you would say it's going to be 2 times 3 to the power, of course, you assign these powers. This is to the power 0 and that is to the power 1. So it means this will become 2 times 3 to the power 1 plus 2 times 3 to the power 0. That's how you convert that to base 10. So this becomes 6 plus 2 times 3 to the power 0. This is plus 2, which means this becomes 8 to the power 10. This is how we convert numbers from other bases to base 10. So this is what we are going to do. Since this side is base 10, let's convert this also to base 10 using that approach as well. So again, let me try and rewrite this here. So this is 125. N is equal to 82 base 10. So let's assign powers to this. This is power 0, power 1, power 2. So after doing so, then we shall begin. We are converting 1 to 5 base n to base 10. So this becomes 1 times n to the power 2 plus 2 times n to the power 1 plus 5 times n to the power 0. That is all going to be equal to 82 base 10. So now we continue with our working there. So this is going to become 1 times n squared, that is going to be n squared, plus 2 times n, which is 2n, plus 5 times n. Any number to the power 0 is 1, so 5 times 1 is 5. That is going to be equal to 82 base 10. So even if we do not put the base 10 thing now, let's proceed like that. So now you realize that we are ending up with a quadratic equation, n squared plus 2n plus 5 is equal to 82. We know that quadratic equations are equal to 0, so let's bring this one this way. So this becomes n squared plus 2n plus, of course, 5 minus 82 is going to give us 82. So that is going to be equal to, what is 5 minus 82? So this is going to become n squared plus 2n. This is minus 77 is equal to, this is equal to 0. This is supposed to be equal to 0. Sorry about that. Alright, so now we have a quadratic equation here. Then from here, we solve it. So solving these quadratic equations, we're supposed to get two numbers. Two numbers giving us a sum of positive 2. And that is when we add those numbers, they're supposed to give us a sum of positive 2. And when we multiply them, they're supposed to give us a product, or the answer should be negative 77. Those are the two numbers. So we start looking for those two numbers. How do we look for those two numbers? Now I'm doing some side work here. We look for those two numbers by looking for the factors of 77. So from here we can say 1 times 77 gives us 77. But if we add them, does it give us positive 2? No. Then we can have, if 2 is not divisible by 77, 3 is not divisible by 77, 4 is not divisible by 77, 5 is not divisible by 77, 6 is not divisible by 77, then 7 is divisible by 77, so we have 7 times 11 is not divisible by 77, we get to 9, 9 is not divisible by 77, then we get to 10, 10 is not, then 11. You realize that we're coming back to this. In other words, we came 1 to 7, then back. We're now coming back to 11 times 77, then back to 77. Now, if you look at, 11 times 7, you look at that. Now we are failing to get the two numbers that are divisible by, we're supposed to get two numbers. When you add them, they give you positive 2. When you multiply them, they give you negative 77. And we have failed to get a pair of numbers that satisfies that. So now whenever you encounter something like that, what that means is that this quadratic expression cannot be, solved like that. So you realize that we are failing to get the two numbers. So what does this mean? This means that this cannot be, this quadratic equation cannot be simplified by simply getting two figures, one giving you a sum of positive 2 and the other giving you negative 77. So what do we do? When you encounter such an issue, it means that now this number you solve it using a technique we call completing the square. So that is what we are going to do now. Since this one, we are failing to get the two factors directly. So we complete squares. So how do we complete squares? Now I expect that the technique or how to complete squares is something that you have done in class. But I'll do a recap of how to complete squares here. So when we complete squares, this is what we do. So it's going to become n squared plus 2n minus 77 is equal to 0. Let me first rewrite that one. So what happens is that I get that number, put it that way, first put it away. So it becomes n squared plus 2n is equal to 77. So when we are completing squares, what we do, we are going to look at the coefficient of the unknown. In this case, the coefficient of n, which is 2. When we look at that number, it's positive 2. So we do this, we divide by 2. We divide the number by 2. That's the first step we do. After dividing the number by 2, then the answer we square it. After squaring the number, the answer we get after squaring, then we add on both sides. So that's what we are going to do here. So we are the number we add on both sides. Those are the three steps. Find the coefficient of that unknown n, which is in this case the coefficient of the unknown. Divide it by 2. After dividing it by 2, the answer we get, we square it. After getting the answer, we've squared it, then we add on both sides. So that is what we're going to do here. So this is going to become n squared plus 2n. Of course, this is going to be equal to 77. So the answer here, the number is 2, right? So it is 2 divided by 2. When 2 divided by 2, what we get? We get 1. After getting 1, step 2 is squaring the 1. So 1 squared will give us 1. After getting 1 squared is equal to 1, then we add that 1 on both sides. So it means that here it's going to become n squared plus n. We add the 1 on both sides plus 1, even here plus 1. Alright, so what does that show us? Now it means that we have ended up with a new equation, n squared plus 2n plus 1 is equal to 77 plus 1, which is 78. So now, when we say that we are completing the square, this is it means that this new quadratic equation we are getting is what we call a perfect square. That's why it's called completing squares. It's a perfect square, and in the perfect square, it simply means that you're going to have two numbers that are, two squares, like two squares that are multiplying themselves out, each other out. So anyway, let's continue. Let's do this slowly. So now that we have created a new equation here, so now this equation, let's now solve it from here. So from solving that equation there, it's going to be, now we're going to find two numbers. Now we're solving this equation here. So we're going to get two numbers giving us a sum of 2 and a product of 1. And so when we say 1 times 1, 1 times 1 gives us 1. 1 plus 1 gives us 2. So meaning the two numbers are 1 and 1. So those two numbers 1 and 1 are what we are going to use to displace this middle portion. So it means that our next step down here is going to become n squared. Then the middle portion that had plus 2n instead, we are going to say it is plus our ones. I don't know where they've disappeared to. Somehow they've disappeared. Let's try to rewrite them here. We have two numbers giving us a sum and product, right? Sum of positive 2 and the product of 1, and we so happens to find them, that is 1 times 1. 1 times 1, we say it gives us 1, and 1 plus 1 gives us 2. So we're going to replace that middle part. So this is going to become n squared plus 2n. So in the place of 2n, we are going to put our roots, these ones, 1n and 1n. So it's going to become plus 1n plus 1n. Then we continue. That is going to be plus this one is giving us 78, like that. So of course, you remember, you notice that this 1n plus 1n is giving us back to n, right? We've just expanded it. So this and that, this is just simply, let me put the brackets here. We put those in two brackets like that. So we continue. That is going to become n squared plus n. Put n outside the brackets into 1, into n plus 1 plus 1 into n plus 1 is equal to 78. So this, of course, is going to become n plus 1 outside the brackets into n plus 1 is giving us 78. Then from there, we shall be having n plus 1 squared is equal to 78. We do square root on both sides. This goes with that. You remain with n plus 1 is going to give us under the square root. Now this square root is either a plus or minus. So this is either plus or minus 78, like that. So this is going to end up being, when we shift this 1, we're interested in finding the value of n. We shift that 1 to take it across the aisle. We remain with n this side. So n is going to become negative 1 plus or minus, into brackets, the root of 78. So this is going to become, n is going to become either negative 1 plus the square root of 78, or it's going to become negative 1 minus the square root of 78. So we go ahead and find the final answers for those two. So so this is going to become, what is the root of 78? We shall simply punch that in our calculator, and here we shall end up with around our answer will be 7.831 or 832 or 0.83, like that. So now our answer is one of these two. Now, since our question here is asking for, we're supposed to be finding the base. This is, we are finding the value of n, and value of n is a base. There is no such thing as a negative base. We are always having the value of n is supposed to be a positive. So it means out of these two answers we've got here, our answer will be a positive one. So we shall leave this one out. So we shall say therefore our value of n is 7.832. And so that's it. That's the first one. So from that very first number, I think you can see they're a bit not obvious numbers, because these are examination past paper question papers, answers. Of course, for you to comfortably be able to do this number, you need to be having a comfortable command on how we complete squares. So if you are not comfortable with completing squares, it's advisable that you do at least, an independent revision on just that specific topic so that you get comfortable with it. It is a very easy topic. So that number is done. Let's move on to the next one. Okay. So without using mathematical tables or a calculator, evaluate that. Now, when you look at a question like that one, of course, somebody can just simply get a calculator, punch in that number, these figures, and they get the answer. So if you just punch in your calculator and get the answer here, you'll get the correct answer, but the question insists without using mathematical tables or calculator. So this means that your working is supposed to be the kind of working that demonstrates that you indeed did not use a calculator. And in numbers like these ones, they are actually trying to test whether you know certain laws. For example, here, when you look at this number, the examiner wants to see if you are comfortable with a concept we call factorization. So that's what they're trying to put to test, because this is 21.35 times this minus that. So they want to test your factorization. Now let me try and simplify this thing for you. Are you seeing this thing of 21.35 here? Then we have 21.35, Now that's like, let's call that something to do with like, remember this 21.35 is times, multiply that by this number. So because of this multiplication sign, it's more like these two are bound together. Let's say 21.35, let's call that, let's assume it's an unknown, it's x. So in other words, this thing would look like this. It would mean it is 41.35x minus x squared. Are you seeing that we are having an x here and an x squared here? So if we are to prime factorize this thing, we see that we are having x as a common thing, so we put x outside the brackets into, this becomes 41.35 minus x. This factorization, this is what they are testing. They want you to see if you know this. Only that this time they've not given you x, they've given you a number that is similar, this one and that one. Let me try and rewrite this thing here. 21.35, multiply that by 41.35 minus 21.35 squared. Divide that by 0.02. So, of course, this common number, we put it outside the brackets. It's the common factor. This and that, because of this multiplication sign, this number and that number, they are bound together. Like the way you would see, like 2x minus x squared. These two and that x are bound together by an invisible multiplication sign in between them. and so you just can't separate them like that. You can only separate them if you put x outside the brackets into 2x divided by x is x minus x divided by x squared divided by x, which is, this becomes 2. 2x divided by x is 2, then minus x, like that. So that's the technique here that we are going to use. This is 21.35, yeah. So it means that this is going to become 21.35 is put outside the brackets into, so what remains here? This remains, we have 41.35 minus 21.35. Divide that by 0.02, like that. So that means that this is going to become, definitely, now that we have shown that we know that, so we deal with what is in the bracket. So it becomes 21.35 into, so you subtract the things that are in the brackets. Now here, even if you use a calculator, the issue they wanted to test is your knowledge of factorization, your ability to be able to put those things outside the brackets like that. So when you subtract those two, probably using your calculator, you end up with multiply that by 20 right there. In brackets is 20, divide that by 0.02. Of course, when we continue there, it's going to become, we can say that this 0 goes with that decimal point moving forward. So we shall end up with 2213.5, multiply that by 2, divide that by 0.02. Yep, let's go slowly. What's 21.35 divided times 2? You end up with 427. Divide that by 0.02. This is definitely going to be equal to 427. Divide that by 2 over 100. This is 427 times 100 divided by 2, which is 42700 over 2. And your ultimate answer will be 21,350. As simple as that. So when they tell you something like that, whenever they ask you that without using a table or calculator, they are always trying to test a certain concept, whether it is the commutative property, or they want you to test factorization. There's a concept they want you to test, and for this case, this is what they wanted to test. They wanted to see whether you can factorize that out, whether you can identify this as a common factor. You put it outside the brackets, then the remaining numbers are, like the way I've treated it. Again, this is also to be able to comfortably do that number will rely heavily on your understanding of how to factorize. It is advisable that you do at least 10-20 numbers on just factorization to be comfortable. And there are very many techniques of factorization, and including them is completing squares, factorizing quadratic equations using completing squares. Factorizing is quite wide. Well, if we are to get into those details, you'll simply let me know. Moving on to the next. So it's the same thing here. Now here they've told you exactly to use factors to evaluate. In another instance, they would just say, without using a table or calculator, evaluate this. But here they have given it to you direct. They are asking you to use factors to evaluate. So you look at it. Remember, when you look at a number like 2x, 2x is actually, it means 2 times x. That is why it's 2x, yeah? So that is how you look at these numbers here. When you see that multiplication there, multiplication, just know those two numbers that are being multiplied are bound together, like the way you'd see 2x. Like when you say 2x plus 4y minus 3, that kind of thing. This 2x is 2 times x, this 4y is 4 times y, but so they are bound together, they move together. Then this plus and minus is, so that's how you see it. So when you say 617 times 793, then here, this multiplication, They are bound together. So from this, you can see that we have a common number here. We have 793, we have 793, we have 793. Yeah. If I'm to simplify this thing for you, it's the same as saying 617x plus 786x plus 597x. That's what it means. And so if you're to simplify this, you realize that x is common, then you put x outside the brackets into this, divide by that is 617 plus 786 plus 597. That's what it's about. But well, this is just, I'm just using the x analogy to just give you a picture of what is going on up there, because up there they are using figures that might confuse you. Since I have broken it down, now let's do the number the way it should be. You are able to see that we are having, 793 as common all through. So we put 793 outside the brackets. This is one number on its own, plus this on its own, plus that on its own. So from each, you're seeing 793 common, so it's 793 outside the brackets into this, divide by that, you remain with 617 plus this is 786 plus this is 597, like that. So once you have used that, you have used factors to break it down like that, the rest is just math. So it becomes 793 into, so you add up the things that are in the brackets, you can use your calculator. So it's 2000. So of course 2000, multiply that by 793, you end up with 1,586,000, and that's your answer, like that. So that's how we go about with that. So here they are saying use factors to evaluate. Sometimes they can simply just tell you without using calculator, evaluate. That's how we go about that one. Moving on to the next one, how we have this here, evaluate this where x is 16 and y is 8. So here we shall have to first, substitute. So y squared, this whole thing is to the power 1 over 6. Divide that by 9x. This whole thing is to the power a half. Of course, that's going to be cool. We said y is 8. So this is same as saying 8 squared to the power a sixth. Divide that by, in brackets, this is 9 times x. X is 16, right? So it is 9 times x, which is 16. This whole thing is to the power a half. Of course, so meaning that is going to be equal to, now let's handle this thing at the top. This thing is the same as saying 2 times 1 over 6. And so 2 times 1 over 6 is going to become by 2 once by 2, 3. So it's the same as to the power third. So this is going to become 8 to the power 1 over 3. Divide that by, of course here we have 9 times 16. Now what is 9 times 16? 9 times 16 is 144. 144 to the power a half, like that. So let's move down. So 144 to the power a half. Of course, now we can go ahead and say, remember, any number to the power half, if I say 25 to the power half is 5. In other words, a number to the power, to the power, to the power half is the same as saying the square root of 5, right? I mean, the square root of 25 is 5. That is what it means. So here, the square root of 144 is a half. I mean, the square root of 144 is 12. So that is going to be, it's going to be 12. Now this 144 to the power half, this is like saying, okay, let me put it here. If 144 to the power half is the same as saying square root of 144. So this is the same as also saying On top, the third root of 8, divide that by the bottom, which is the square root of 144. Now, those are laws from your topic of indices. So let's try and find the third root of 8. So we shall do some side work here. The third root of 8. You can punch that in your calculator and you'll get your answer correct. Or you can say that's by 2. Divide by 2, you get 4. By 2, you get 2. And so after prime factorizing them like that, you divide them in groups of 3s because you're looking for a third root and you just pick 1, 2. And so that means that the third root of 8 is 2. Divide that by the square root of 144. Let's also calculate the square root of 144. So 144, I'll say by 2, that is 72 by 2. Divide that 72 divided by 2, you get 36. By 2, you get 18. By 2, you get 9. Then by 3, you get 3. So from there again, because it is square root, you group these numbers into 2, 2, 2. Remember when it was third root, we grouped them into groups of 3. So this one, because it's square root, we group them into 2, and then you just pick 1 in each group. So it means this is going to pick a 2 here, pick a 2 here, pick a 3 here. So it becomes 2 times 2 times 3, which is going to give us 12. Because 2 times 2 is 4, 4 times 3 is 12. So that's how we end up having here. Divide that by the square root of 144, which is 12. So I did these workings to show you the difference between finding a square root of a number and finding the third root of a number. Here, the third root of 8, we grouped them in, after prime factorizing, we grouped them in groups of 3, and the answer is 2. So that's how we end up with 2 over 12, and that is going to become by 2 once by 2, 6. So the answer is a sixth, and that is the answer. So again, this one, to be able to do this one comfortably, you require knowledge on, to be comfortable with, what is it called? With, you're supposed to be comfortable with indices, the laws of indices, and it goes hand in hand with logarithms, but mostly the laws of indices. So moving on to this one, find the lowest common multiple and the highest common factor of 54 and 84. So again, this is 54, that is 84, like that. We factorize them together like that. So we shall begin by factorizing them. We begin with common factors, like prime numbers or something like that. So we begin by 2. If I put 254 divided by 2, what do I have? I have 27 here. 84 divided by 2, we have 42. Now you realize that this value of 2 was able to divide both of them, so I will circle it because it was able to divide through by both of them. So we proceed to the next. These two, let's divide them through by 3. 27 divided by 3 is 9. Then 42 divided by 3 is 14. So you realize that 3 was able to divide divide both numbers. So we also circle it, or you mark it. Then move on to the next. We can still use 3 here. 9 divided by 3 is 3. 14 divided by 3. Now 14 is not divisible by 3, so it shall remain as 14. So we can ignore that one. We won't circle this 3. Won't be circled because it was not able to divide both of them. Then here I can continue and say divide that by 3. 3 divided by 3 is 1. 14 divided by 3 is not divisible, like that. Again, we shall ignore that because 3 has not divided both. Then I shall come here and put 14. 14 divided by that is 1, 1, like that. So we go ahead and look to go ahead and multiply everything that is there, everything. So to get the LCM, we multiply everything, which is 2 times 3 times 3 times 3 times 14, and then we shall end up with 378. That's the LCM. So for us to be able to find the highest common factor, it is these ones that we're able to, it's 2 and 3. The only two numbers that we're able to divide through everything, so that's going to become 2 times 3, which is 6. So 6 becomes the highest common factor, and this 378 becomes the LCM, the lowest common multiple. So that's how we go about that one. Moving on to the next. So we have A star B is A over B and B over A. Evaluate this and that. This is like saying this A is that, like that. Then this value of B is this. And of course that star you can see. So they're asking us to, we substitute that in this, and that's it. A over B plus B over A is going to be given by, so our value of A is a half, so we shall say it's going to be a half. Divide that by B, which is 2/3. Let me put that like that. Plus B over A, our value of B is 2/3. Divide that by 3. Our value of 3 is, our value of A is a half, like that. Just that. Then we continue the working. So this is going to become, let me put this in this own bracket. This is a half, divide by 2/3 plus 2/3 divide by a half. So of course you know that we are going to find the reciprocal here. This is going to become a half. Multiply that by 3 over 2 plus 2/3, multiply that by 2 over 1. So from there we shall end up having, of course, that is going to be 3 over 4 plus, that is 4 over 3. So from there we find the LCM of 3 and 4. The LCM of 3 and 4 is 12. 12 divided by 4 is 3. 3 times 3 is 9. Plus 12 divided by 3 is 4. Times 4 is 16. And then we shall end up with 25, divide that by 12. And that is an improper fraction. So of course this is going to become two whole numbers, 1 over 12. So that's the answer we get for that. Two whole numbers, 1 over 12. Moving on to the next. This one is related or similar to what we had done earlier. You can try it out and see if you can get the value of n yourself. So it is 212 to the power n is equal to 25 to the power 9. It is similar, but let's take note here. The number we did before, let's get back to that number. Do you see this number that we did before earlier? This number, this was to the power n, and this was to the power 10. So since this one was to the power 10, we had to only change this side to the power 10 so that we are able to find the value of n. But this one is different. This side here is to the power 9. This one is to the power n. Now for us to be able to solve this value of n, both of these must be in the same base. Oh, but I don't mean power 9 or power n, I mean base 9 and base 10. So these ones need to be in the same base. So it means that we are going to change everything to base 10. Then after changing everything to base 10, then we shall be able to find the value of n. That is the approach. So this is going to be 0, 1, 2. I'm assigning powers, even this is 0, 1. We change to base 10 on both sides. Then that's when we shall be able to find the value of n when both things are being converted to base 10. So this is going to become 2 times n to the power 2 plus 1 times n to the power 1 plus 2 times n to the power 0 is going to be giving us 2 times 9 to the power 1 plus 5 times 9 to the power 0. So this is going to become 2n squared plus n plus 2 to the power 2n to the power 0 is 1, which is plus 2, is going to give us 2 times 9, which is 18, plus 5 times 1, which is 5. So we shall end up with 2n squared plus n plus 2, giving us, so this is 18 plus 5, which is 23. Yep. So like all quadratic equations, they are always equal to 0. We could transfer that to this way. It becomes 2n squared plus n plus, of course, that is 2 minus 23, giving us 0. So this is 2n squared plus n, then that is going to be minus 21 is equal to 0. So here we have a quadratic equation and we are supposed to solve it. So remember, quadratic equation, we're supposed to find two numbers. Of those two numbers, they're supposed to give us a sum. Here we have positive 1, that's positive 1, and a product. The product here is this value, multiply that by the last value. So a product of 2 times negative 21, which is negative 42. Now you might be confused that how come we've done it differently here. Remember, in the first instance, it's the same thing, by the way. In the first instance, let me get back to the first number. You remember the first number here? We're looking for two numbers giving us a sum. I'm looking at this equation now. We are looking for two numbers giving us a sum of positive 5 and a product of negative 82. It's actually negative 82 times the coefficient of n squared here. Now the coefficient of x squared here is 1, so it's 1 times negative 82, which is the same. Actually, not 82, 77. We are supposed to be looking at this here. Two numbers giving us a sum of positive 2 and a product of negative 77. This was because the coefficient of n squared here was 1. So it's the same as saying 1 times negative 77, which remains as negative 77. So it's the same thing here. So it's two numbers giving us, here we had 2 here. So two numbers giving us a sum of positive 1 and a product of negative 42. So we start looking for those two numbers, and those two numbers, we shall look for them using the products of negative 42. So that's going to become 1 times 42. Then we have 2 times 21. We have 3 times 114. Then I think 4 does not fit in there. 5 won't fit in there. We have 6. We have 6 times 7 here. So if you look at this 6 times 7, 6 times 7 will give us 42. And then when we add the 2, if you make one of these two negative, if we make this 7 negative, negative 7. 6 times negative 7 will give us negative 42. Then 6 plus negative 7 gives us negative 1. If you add those two, it gives us negative 1. So the two numbers are 6 and negative 7. So these are the two roots. So they are the ones that are going to apply there. So it means we come back to our working, it's going to become 2n squared. So this middle part here plus n is going to be replaced by these roots here. So it becomes plus 6n minus 7n. Take note that this plus 6n and this minus 7n is still going to give us plus n up there. Then we continue here, that is minus 21 is equal to 0. So we proceed, it becomes 2n squared plus 6n minus 7n minus 21 is equal to 0. So we bracket them off like that. We find the common factor here, factorization. So when you factorize there, the common factor here is 2n. So put 2n outside the brackets into n plus 3 minus the common factor here is 7 into n plus 3. That is going to be equal to 0. Right, so this becomes, the two numbers outside, the outside numbers get their own bracket, so it becomes 2n minus 7, put those outside the brackets into the numbers in the bracket, this one and this one get their own bracket here, so this becomes n plus 3 is equal to 0. And then from there, we can simply come and say either 2n minus 7 is equal to 0 or n plus 3 is equal to 0. So we shall end up having 2n is equal to 7 divided by 2 divided by 2. This goes with that, n is equal to 7 over 2 like that, or n is equal to negative 3. So of course here we are looking for the value of n, and if you look at our question, the value of n is supposed to be this, a base. And we do not have such a thing called a negative base. So since one of our answers here is a negative, so we eliminate it and we take this one. Of course 7 divided by 2 is the same as 3.5. So we shall say therefore n is equal to 3.5. And that's our answer right there. So moving on to the next. Okay, evaluate this, leaving your answer in that form. So evaluate that 5600, divide that by 80,000, leaving your answer in the form of a times 10 to the power n, where a is an integer. So in other words, they want you to find the answer to this, but your answer should be in standard form. This is like standard form. Okay, so this becomes 5600, divide that by 80,000. So we can, subtract those two, we end up with 56, divide that by 800, like that. So what is 56 divided that by 800? That's going to give us 0.07. That's the answer, but they're asking us that the answer should be in the form of a times 10 to the power n. And they're telling us that the value of a should be between 1 and 10, and the value of n should be an integer. So that is going to become, of course, this means that this decimal place is supposed to move, 2 steps ahead. So that means it's going to become 7.0 times 10 to the power, that's going to be negative 2. In other words, it's going to move, this decimal point here should move 2 steps in the reverse direction to get back to where it was gotten from. That's why we're saying 10 to the power negative 2. So for you to be able to have done this number, you needed to have a command on, how to make numbers into standard form. This is just revision, so I am not going so deep into the nitty-gritties of how to do certain topics, but in case you need my help in that area, simply let me know and we go deep into that. So here we are, we have another number here. Find the highest common factor of 18, 45 and 42. So we are just like the number we did before, 18, 45 and 42. That's the number we have. So from here, okay, so we get started. We do it like before. We factorize it by 2. 18 divided by 2 is 9. Of course, 45 can't be divided by 2, so we can leave that as 45. Then 42 divided by 2 is 21. So we shall not tick off 2 because it was not able to divide 45. So we get to the next, let's use 3. 9 divided by 3 is 3. 45 divided by 3 is 1, 5. Then that is 7. So you find that here this 3 was able to divide through everything, so let's mark it. So moving on to the next, we divide through by 3. 3 divided by 3 is 1, 15 divided by 3 is 5, 7 divided by 3 is 7. That can't happen. So again, we proceed, divide through 5, that is 1, 1, 7. We use 7 here, and we shall end up with 1, 1, 1. So from here, we now find what is the highest common factor. The highest common factor. The highest common factor is the number that was able to multiply through everything, which is 3. Of course, if there are multiple numbers, you multiply them. So here the answer is 3. Then what about our LCM? Our LCM is we multiply everything here to get the LCM. So it's going to become 2 times 3. That is 2 times 3. This 2 times that 3 times 3 times 5 times 7. And of course 2 times 3 is 6 times 3 times 5, which is 15 times 7. So we shall go ahead and get our answer there. And our answer there is 630. That's our LCM. So finally, let's get to the final answer, the final number related to what we had done earlier. 135 base n is equal to 75 base 10. This one is already in base 10, so let us convert that to base 10 as well. So let's assign the powers, that is power 0, 1, 2. So this is going to become 1 times n to the power 2 plus 3 times n to the power 1 plus 5 times n to the power 0 is going to give us 75. This is already in base 10, so there is no need to convert it. So this is going to become n squared plus 3n plus 5 times n to the power 1 is 5, giving us 75. So this is going to become n squared plus 3n plus, of course, this 75 comes here, it becomes minus 70 is equal to 0. So in other words, this quadratic equation has become n squared plus 3n minus 70, giving us 0. So from that quadratic equation, to solve it, we need to find two numbers. One giving us a sum of positive 3. The other is giving us a product of 70. Of course, it's supposed to be 70 times the coefficient of n, which is 1. So which is negative 70. So how do we find those two numbers? We find those two numbers by multiplying, the products of 70, of which these ones are going to be, let's find them. We have 2 times 35. 3 doesn't fit in there, 4 doesn't fit in there. We have 5 times 14, 6, then 7 times 10. So if you find 7 times 10, 7 times 10, we make this 7 negative. So 7 times 10, negative 7 times 10 gives us negative 70. And then negative 7 times plus 10 gives us positive 3. So these are the two answers that are going to work, this negative 7 and that 10. So we get those answers and we are going to use them to displace the middle part. So this is going to instead become like this. It becomes n squared. Then the middle part, which is plus 3n, is going to be substituted by our roots, these ones here. So it becomes minus 7n So it is n squared, then it's going to become minus 7n plus 10n, then we come to minus 70 is equal to 0. So we put that in brackets, we put this in brackets. So this becomes here, this is going to be, put n outside the brackets into n minus 7, then that is going to become plus, the common factor there is 10 into n minus 7 is equal to 0. So of course the things outside the brackets will go alone, n plus 10 into the things outside the brackets, which is n minus 7 is equal to 0. Alright, so that becomes either n plus 10 is equal to 0 or n minus 7 is equal to 0. So here the value of n is negative 10, here the value of n is 7. So since we are looking for number bases, we shall say since there is no negative base, we shall conclude by saying that the value of n is 7. We pick on the positive number and that is our answer. So that concludes this session on just examination style numbers on numeration. And in numeration, I think you've been able to see that we were able to cover some exam type questions that are set on things like, factors, multiples, prime numbers, sequences, and number bases. Yeah. Of course, if you want to see more of these kinds of numbers, to do more of these kinds of numbers, just let me know. And then also, of course, if you are along the session, I've been talking about specific topics that you're supposed to be good at to be able to flow these numbers well. For example, you've been able to see that you need to have a command on factorization. You need to have a command on how to solve actually quadratic equations by factorization, and you're supposed to have a command on things like indices and series and some number somewhere. And yeah, I've been talking about some of these topics along the way, completing the square. And if you feel you do not have a command in any of those topics and you feel we need to dive deep into those topics, let me know and we will be able to do so. Otherwise, this is it for this session.